Welcome to Physics 101. Today I will be introducing you to motion in one dimension. We will be covering in this lesson displacement, average speed and velocity, as well as acceleration. We'll start first with displacement. Displacement is the change in position of an object. As we can see, we have the equation delta x equals xf minus xi. Delta x in physics means the change in, and xf equals the final position, while xi is the initial position. So to solve a displacement equation, we would need the starting point of the object and the final finishing point of the object. And by subtracting the two, we will then get displacement. Displacement is not always equal the distance the object travels. What is meant by that is, for example, if a lion was to start at his home and the lion travels 30 meters across the field, and we measure the displacement across the field, and then the lion decides to come back to his home, and then we measure again the displacement of the lion coming back. The distance traveled would be 60 meters, but the total displacement would be 0. Also with displacement, our results can be positive or negative, depending on which way on the x or y axis the object is moving. Here's a displacement example. We have a ladybug that starts at 1 meter on the ruler. The ladybug then travels all the way to 12 meters on the ruler. What is the ladybug's displacement? At this moment, please pause the video to solve and receive your answer. Alright, the answer is 11 meters. We take with the final spot the ladybug lands, which is 12 meters. We minus it by where the ladybug started at 1 meter, and then we receive our answer of 11 meters. We'll do more examples in class. Our next thing we're going to talk about is average velocity and average speed. With these two terminologies, it is very easy to get them confused. One may think that velocity and speed are the same thing, when in fact they are a little different. For average velocity, it's the total displacement divided by time interval during which the displacement occurred. So as we see in our equation here, we have that the average velocity is equal to the change in x over the change in time, which then is equal to where the object finished minus where the object started, all divided by the time when the object finished minus when the time the object started. Now with velocity, it does contain a direction and magnitude, not just magnitude. Now average speed is the total distance traveled divided by the time of the distance traveled occurred. For this equation, we see that average speed is the distance traveled divided by the time traveled. The difference here is average speed only contains a magnitude. So the biggest difference between the two is that average velocity has a direct direction included with it. Here's an average velocity versus average speed example. John is running in a race and finishes the last 400 meters in 50 seconds. What is his average speed, and what is his average velocity for the last 400 meters? Note the last 400 meters is in the south direction. Now please pause the video to answer this question. Alrighty, so the answer for this question is the average speed is 8 meters per second and the average velocity is 8 meters per second in the north direction. You see, both answers will be the same, except the velocity is going to have the direction. Now our last topic we're going to talk about is acceleration, the rate at which a velocity changes over time. The object accelerates if the speed, direction, or both change. So as we see here, the acceleration equation is a change in velocity over the change in time. Now with acceleration, it contains direction and magnitude just as velocity did. A great example of this is a car at a stoplight, and as soon as it turns green, the car is speeding up, so the velocity of the car is changing, as well as the time that's occurring. So that is a great example of acceleration. So what have we covered? We have covered displacement, differences in average speed and velocity, as well as acceleration. We will go over more in class. As you see, I have a link here to a linear motion simulation that is a great example of all three of these ideas. So if you get time before class, go on this simulation and play around and tell me what you have received from it. Alrighty guys, I will see you guys in class, and just remember to answer the 3 questions I have posted below the video for you. See you in class.